Let me share screen. Yeah, today we'll start with another new topic. And in the last class, we had completed exception handling. Today we need to start another topic. Maybe we can start with threads or regular expressions. Anything should be fine for us. So whatever it is. So shall we start with threading today? So let's do that today. We'll start with threading and see different types of thread process and everything. This is also something really important in development. Okay, but not all development needs this threading because I do automations for our process management. Generally, we don't need threading much, but there are certain projects where we need threading. So when you are synchronizing data, and if you want to avoid data inconsistency issues, right? In such cases, implementing multi-threading is one of the best choice. Okay, so anyhow, let us talk about threading. What is a thread? What are different types of methods available in threading? All that we discuss step by step. So when we talk about thread, thread is a process which performs a specific task. So that is what a thread is. Sorry. So it is a process which performs specific task. And what is multi-threading? Simple. A group of threads executing parallelly is known as multi-threading. Okay. Then one important thing about threads is a lightweight process. Generally, thread utilizes less system resources because threads uses shared resources. They used shared RAM, shared thread pool, shared thread scheduler. So the resources that threads are using would be shared so that it uses less system resources. That is the advantage with threads. Okay. So, and also when you use multi-threading, when you implement multi-threading, it also inculcate parallel programming. So with multi-threading, we can achieve parallel programming in this Python. Okay. And you can see here, thread uses shared resources like shared CPU, shared RAM, shared hard disk, something like that. Okay. So that's what happens here. Now, finally, what is a thread exactly? Simple. This is nothing new for us because we almost did so much in Python so far. We covered core Python, advanced Python. We did so many programs. With all this knowledge, doing all these topics is simple for us. Only we need to understand that concept. So what is thread here? A thread is a sequence of instructions within a program that can be executed independently of other code. So when you have multiple threads, each thread executes on its own. So that is where we can get into this concept of parallel programming. Okay. And finally, what is that? Multiple threads can exist within one process, right? Where this is important for us. Each thread contains its own register set and local variables. So even though we have multiple threads, every thread have its own register, have its own local variable stack. Generally local variables are stored in stack. Sometime back I explained stack scenario, remember friends. But one thing what threads do is all threads share global variables. And these global variables are stored in heap. And you know about heap by now. Because sometime back again I explained what is heap, how data is stored inside heap, what kind of variables are stored in heap, all that. So what is the point here is all threads share global variables and the program code which they share are stored inside heap here. So this is the idea about quick idea about threads. I think this should give you some understanding. What is that? What is exactly thread? So why? What is the advantage with threads? If somebody asks you, it's a lightweight process, generally uses less system resources because they use shared resource, like say shared CPU and shared RAM. And also, when we get more deeper into that, every thread has its own register and local variable stack. Okay, but what is global for them? So for them, all threads share global variables and the program code. That's it. So this is the idea about multi-threading. And then the second thing is multitasking. There is a difference between multi-threading and multitasking. If somebody is asking you, what is the difference between multi-threading and tasking? Multitasking is multiple programs executing parallel. That is multitasking. Multi-threading means in one program, if you have multiple tasks, it is something like this. If you just see with a small diagram, multitasking is simple, friends. Right? You have something like one, program two, program three, right? So something like this. This is actually a media player. Okay. And second one, you are executing PyCharm. And third one, you are running a another one. But we can take it as a your one more. This one, photo viewer. Okay, something like this. Here, if you see this, everything is a separate program. Player is altogether one program. Python, PyCharm is one program. Photo viewer is one program. So multitasking means multiple programs executing one by one. That is multitasking, or multiple tasks executing program one after the another. So all these so when group of programs are executing parallelly, then we call that as a multitasking. So generally this involves multitasking. Okay, executing multiple programs together. What is multi-threading then? Multi-threading means, see, it's something like this. Let me just show you. It's very easy to understand. Suppose you have a thread like this. You have a program like this. In this program, you have again some small programs. So you created multiple threads here. Okay, that is one thread, one more thread, something like this. Okay. So here, this is thread one. Okay. And this is thread two. This is thread two. And this is thread three. Something like this. So here you can see here what's happening in this. In one program, this is a program. So that program is divided into some small programs called threads. In this program, we are executing, we have multiple threads. And in one program, if we have multiple threads like this and executing, and these executes parallelly. So all these threads executes parallelly. And this is called multi-threading. You got it right. If one program is divided into subprograms like this with threads, and this is called multi-threading. Got it right. So this scenario, right, is multi-threading. So that is difference between multi-threading and multitasking. In multitasking, we have separate programs and each program run on its own. And that is what multitasking is. Multi-threading means in one program you have different threads, or it is divided into multiple threads. One program is divided into, and each thread is one sub process here, or one process. And all these threads try to run together. I'll talk more about this in some time. And this process is called as multi-threading. You got it right, friends. This is the idea. Just a quick idea. If one program is divided into multiple threads, it is multi-threading. If multiple programs are executing parallelly, it is multitasking. Simple. Right. So that is the idea. So that is what we are executing multiple programs parallelly is multitasking. Executing multiple threads, and multiple threads exist in one program, right? Within one program, if multiple threads are running parallelly, it is multi-threading. Hope this should give you a clear idea. And and here multitasking is a heavyweight process because we need a separate RAM for each program and separate CPU for that. And definitely we need separate resources here. Mostly we talk performance in terms of RAM and CPU. When you are doing multitasking, each process need a separate RAM, each process need a separate CPU. You got it right. So that's why this is a heavyweight process, whereas thread is a lightweight process because threads share CPU and RAM. Whereas in multitasking, each program needs separate RAM and CPU. That is difference between multi-threading and multitasking. Right. Finally, this is the just a quick introduction to difference between threading and tasking. Now we are going to get quickly jump into the API of threading, thread API. So we'll quickly just do one thing. What is that we do? We just quickly see thread in Python, not in Java. We'll just see threads in Python. So we just get into the documentation of Python because we don't need much of other things. We need a quick documentation. So what is important in Python? Thread class. Okay, let's see our thread objects. Yeah, this is a thread class. Okay, fine, that is fine. And you, this is important. See here, friends. What is that you should see is you should check with thread class. And thread class is present in this module, that is threading module. If you want to work with thread, we need a threading module. And this is the built-in thread class, right? And this is the API. API means all built-in. If you want to implement multi-threading, already we have built-in classes. We just need to import them. In this thread, the very important methods are start method. This is important. And apart from that, run is also very important. And join is important. Okay, these are all other methods just to get some name, set name, all this, some just regular methods. That's all. Okay, if you want to get name of thread or if you want to provide some customized name to a thread instead of default name, if you want to provide some customized name, then you can use get name, set name, all that. And is alive means checking if thread is running or is alive means if it is running. So if a thread is running, this returns true, else it returns false. And if you want to set a thread as daemon thread, daemon means something which is running at the in the background. So there are so many background threads when you start working in some development. We also might create background threads. Suppose you see when you are working, suppose you are using a PyCharm, friends. At the same time, what do? You try to open a media player. You keep listening songs, but you don't open it. But you will be working with PyCharm, but songs will be playing in the background, right? What happens? Your OS will just convert it into a background thread. Similarly, you open so many windows here, but you don't work with all those windows and just minimize it and just focus on this particular PyCharm or something. Then in such cases, remaining things will be running as background threads. You got it right, friends. So that is the idea. So daemon is that. What is that? Daemon is nothing but it is nothing but if you want to make your thread as a background thread and run it, then we can make it as a daemon. You got it right. So how to create a daemon? If you want to make a thread as daemon, you should use set daemon. And if you want to check if it is a background thread or not, you have to use is daemon. That's all. So this is very simple. Right. I hope this is clear. And apart from that, another important scenario is I'm just quickly walking through the API so that because some of our friends have asked me about multi-threading, right? Because they were using in their projects, they need this multi-threading. So I just want to make sure you understand what is needed for you for your project. That's all. So everything is here. So what you can do is, of course, you can also get this just sharing this documentation. Whomever see any documentation, any people who work on multi-threading, they take it from here only, friends. You got it right. They just try to use this documentation. Even people from different websites also, what they do, they try to just create a fair copy from this documentation only. Got it now? So now I hope that is clear for you. I'll explain all this. We are going to work with all this, so I am not going too deep into this. But I will give you a clear idea why, what is run, what is start, what is the thread life cycle, what is join. Okay. So all that we'll discuss step by step. Then another thing in the API is locking. Locking means suppose if you want to implement some synchronization, synchronization means usually with threads we have data inconsistency issue. To avoid this, we implement locking scenario. Locking is a kind of synchronization. And in that we have two important methods. One is acquire. So, and another one is release here. So we got it right. These two are important. And locked method. One more is we have a locked method. So this is just to check. You can see here if a lock is acquired. More than this locked or this thing, acquire and lock are very important for us. Okay. We'll see that. We'll implement a scenario called synchronization. In that you understand about locking. I don't think we need to this return lock again. Okay, because lock is enough for us. If needed, we'll talk about return lock. So mostly these are important for us, friends. Got it right. If we should discuss about semaphores, then we'll talk about it. Else, otherwise, we will. If it is needed, let me know. If you need to talk about semaphore, we will cover this. Else, we don't need semaphore as well. Okay. So finally, this is overall thing about thread API. Mostly this covers thread API. Okay. So now what do we do? Let's start with threads and understand how this API works, how to create threads, right? And see the multi-threading process and how it works and how we can apply all this as well. This is interesting again. Okay, whatever we are doing here, thread process is an interesting program. But you got an idea, right? This is the API, thread API. Okay, so and finally, you should remember we have a built-in thread class in this module threading. So let's start into the program. What you can do is we can create a simple program, right? So this is the very simple. You are importing this module. See here, if you want to implement threading, we have to implement this. Okay, we can do one thing. We can just you know use this a little later. This wait process, you don't need to apply join. Join thing we'll bring in later. First, in the first program, let's just try like this, creating threading like this. Okay. So this is the program. And this program is a very simple program. What is that we are doing? We are using a module threading. This is a built-in module. And then apart from that, there are different ways of creating thread programs. And I have added both approaches with a thread class approach and with a like creating methods and converting those methods into thread concept or converting them into threads. So that is what we are doing. This program is a so simple program. You can see here we are printing numbers, that too just printing. Whenever we call print numbers, it just prints range of numbers till 5, 0 to 4. So that is what this does here. And we are creating a thread here. To that thread, we are passing this to that thread class. This is a constructor, right? To this constructor, we are passing a key parameter. That key is target equal to, we have, this is a built-in parameter. To that, we have to assign this function name, right? And then we ask it to run. So let us try this. But here, this is a straightforward thread. We are not actually implementing any thread methods directly. that exclusively if you are going more into threads, we have to override run method. That is important. That scenario we are not implementing here, but creating a simple thread without overriding run method. I'll talk about that. But let us do this example so that it's easy for you to get idea. So what is the point here? We can try on our own. We don't need to copy and paste as well. So what do we do? Let me just right click and say new Python file and then thread. I can just write threading or multi-threading. That is enough. Next one, you can say import threading. That is one thing. Just create a simple method. Just like as we see, we can use print numbers. Okay. You can create any method, friends. It's not like it should be this one only. Okay. And then colon. So what is that we do? We need to, for some I in range of some 1 comma 10. Okay. And then colon, you just print F. What is that? Number is, you can just print that I here. Okay. And then that colon. Okay. That's all. You can just keep it like this. And we have created a simple method. Let's create a thread here, some T1 equal to some threading dot some thread of, okay. You can do one thing dot. You can create an object by calling it from, you do one thing generally, th, we do one thing. Just create an alias. Okay, that's much more better thing when you are working it with any this thing here. Okay, should be fine, no problem. So what do you do here? Alias is the best practice. Okay, so here T1 equal to T dot thread thread. Okay, put a create a constructor here, and then there is a method like, what is that? Target, right? To this target, just pass this. What do we do? Copy this and pass this function as a parameter. Okay, just change this printer and then add a print here. So we created a thread successfully, but just this is just a newly created state. This state, what we call it is a newly created state. Once we create object, it doesn't do anything. It's just in a new state or newly created state. Now, if you want to start thread, right? Then it won't start it on its own, friends. It won't start on its own. Then what is that you should do? You should call start method on thread. Only when you call start, then it achieves the behavior of thread. Until you call start, thread never behave like a thread. Also, suppose you see, we'll talk one by one. So when you call start, what happens? Then your thread is registered with the thread scheduler. You got it right. This is important. When this registered, only when you call start. When you suppose without calling start, you created a thread object and now you pass that print numbers. You can also do this T1 dot, you can say this is not calling coming. Okay, no problem. I'll show you with run method that gives more sense. Okay, so let me uncomment this. But the point is, once you create thread object, understand the life cycle of thread. If you want to register thread with the thread scheduler or thread register, then you have to call start method. Okay, now run this. This when you call start is going to call this print numbers. Let's run this now. Run thread. What happened? I generally knew demo.py. Yeah. Why I'm getting this? This should not come to me. I don't have any.
I think the first line will come automatically, right? From demos win 3.
Oh, this is. We don't need this. But I think this has been. I didn't see that. Thank you for reminding. I think that has been imported automatically. That is the reason. Yeah. Now let's run this now. CHREAD. This is fine, right? Okay, I got it. The issue is with this .py file. I understood now. What I did is I used. I should refactor it. Sorry. Sometimes we keep going wrong. Rename this to instead of threading thread underscore test. Okay, and then also that is the issue. So this thread module is there, right? Never, don't try. This is a bad practice. So I didn't see that properly. If any built-in module is there, don't try to save your program name with that built-in module names or built-in class names, built-in method names. That is a bad practice. Why we are seeing this warning here is because so this is something not importing the built-in one. It is using the one which I overridden here, threading.py. Anyhow, I'm changing that. That should resolve the issue. So now what I can do, I can simply do something here. What is that? Import. Now you can see there is a threading here, threading as T. So this should give us a proper programming, this thing, proper thread experience. You got it right, friends? The mistake I did is this. So I tried to save it with the same threading name. So that was the issue why I had it. Okay, let me run this now. This should work fine now. You can see here. So it is running from 1 to 9 as per the expectation. You can also do one thing. You can create multiple threads. Suppose you can create one more thread here, and then what you can do, just name this to T2, and here also you can do one thing. Copy this and put here, and then say T2, and then right click, and you can run this. Now you can see 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. Again, run this. This is working like a normal thing. 1, 2, 3, 4, 5. You can do one thing. 1, 2, 3, 4, 5, 6, 7, 8, 9. We need a little bit of thread experience. Yeah, this is what we need. See, now there is a jump in the output. Can you see that there? What happened? 1, 2, 3, 4, 5, 6. And in the middle, you can see there is a change. It didn't complete the first, whatever thread it is, thread 1 or thread 2. The for the one, you can see that without completely executing one thread, the other thread just pitched in. And this is the concept of multi-threading actually. Yeah, of course, this is a data inconsistency issue, but I want to show you this just to understand the concept of threading. Here we have two threads, both threads try to execute same time. So when you say start on both threads, T1 dot start, T2 start dot start, both threads will get into a race condition. And both threads try to acquire the thread scheduler. You got it right. I'll explain the life cycle with very much detailed thing with a diagrammatic scenario. But this is what I want to show you. What is that? When you have multiple threads, each thread try to run on run first. In that process, they get into a state called race condition, and we cannot predict which thread starts first and which thread starts later. You can also do one thing then. We can also give a name to the thread. I think what is that you can do? T1 dot set name. You can give it as this is John thread. I'll just give it as a, if you can name as we like, friend. I just for this thing I am giving like this. For one thread I put as John thread. The other thread I put it as what is that I'll do? I put it as Peter thread. Okay. You can give any name, friends. Okay. It should be fine. So the other one is I put it as Peter thread. Now what we can do is T1 dot on start directly. We are not able to see. We have assigned a name. So then while
Need to keep
starting,
T2 dot set name
yeah, yeah.
line
Oh,
name.
sorry, sorry. Yeah, yeah, yeah. We can give a name like this. And while running also, we can get the name of that thread. Once we set some name, oh, just a minute, we can do one thing. Let's take this scenario. How to, just to differentiate, this is interesting. Set and get name, thread, name for threads. Let's do that. Just add a name thing to this in Python. Again, it's going for Java. Java thing is over. Okay. Simply, this is interesting one. Giving a, these are called name of threads. That's all. Nothing more than that. Yeah, this is one way. There is another way of naming threads as well. Instead of set name, this is chat GPT is better. How to set and get name for a running thread. We should stop this. It's going to Java in Python. Actually, we can just continue, but I just want to quickly show you. Yeah, this is what, if you want to just checking. So you can see here, right? This is fine. We created a thread name. Only thing we need to get that name. For that, the approach is this. Let's use this. Just put this in our code here. Yeah, we can either put inside this. You can just directly use alias name here. T dot current thread. And with that current thread, we can get the name. Then we can see which thread is running. Okay, so fine. Let's run this now. And we set name, just named it as John thread and Peter thread. Let it be like that. You can name anything, friends. I just gave some random name. So right click, run thread. So you can see here now, this gives you a clear thread is running. Which thread is running? So this is how you can get the thread name. Whichever is running, you can see that. The just thread that just started is the first thread is John thread here. You can see when you say start, this is called, and then Peter started. Now run this again. Again, I think this is going properly. One thread executed again. Three that John thread T1 thread executed completely, and then it has gone to 3 2. But this won't be the case always with threads. Okay, right click and run it again. You should see some difference. Not every time you see, but when you keep some time back, you see there is some kind of overlap, right? That happens in threads because both threads try to execute at same time, which might run into a state called race condition. So now they are going fine, no issues with that. Again, run it. You should keep checking. Sometime, somewhere it will get that overlap. Not a problem. This should be fine. Okay, you can test it, friends, not a problem. But what is happening is you can create how many threads you want to create, and then you can call start on that. Okay, and they try to run parallel. That you have seen yes, in some scenario. You have seen that approach, right? So I'll just explain quickly the execution flow. Let me share this code with you. A simple code. Now after that, so this is done, right? I think you got some idea how to create threads. This is one approach by directly having some method and through method, right? What we are doing, we are converting it into a thread by passing that method to that thread constructor. So that is one approach. There is another approach where this is something really important for us, right? So using all methods in one shot. What is that? Run method, start method, and then we go for join one by one. So we have seen a simple approach of implementing thread. Next approach, creating a thread class by inheriting built-in thread class. Got it, right? It's creating a child thread from existing built-in thread. Now these are the threads to implement threading. Sorry, steps to implement threading. What is that? Inherit a class from a thread class, which is available in threading module. This is what we should do. This is how just you create some thread and you inherit this thread from built-in thread and you override run method. This is important. We override run method. So that is one something because this is where you implement that thread specific logic. This is always a recommended approach where you write that thread specific logic inside run method. You got it right. Run is very important for us. Maybe if you see here in the API, somewhere we have seen, right? So start is okay. I'll explain now. This is not a problem. Run. So exclusively run. What is the method representing threads activity? Okay. So this is something exclusive. And generally what we do in threading is we override this method in a subclass. You got this point? So what is that we do? We override this in a subclass. That is what we should do. You got it right. So that is what we should do here, friends. So now, if you see here in this documentation as well, so what is that I did? I inherited a thread class and I override this run method. You know the concept of overriding, right? So I did override run. And what is that we should have in run method? Something specific to thread activity. When you are doing multi-threading, whatever the thread activity that has to go into the run method, whatever the thread activity we should implement. That is step one. What is step one? Inherit a class from a built-in a thread from a child thread from a built-in thread, override run method, and then create step two, create thread object. Step three, call start method. This makes much more better this thing. Now you can see here we do one thing. We can also create a program up quickly ourselves. We do one thing. Let's create one more. So I put it here fine. I'll just change that later. Or otherwise, let me add all this here itself. Python file thread test. Then what is that you do? You first import. We are creating a thread in a different way now as T. Okay, and then class some thread one. You can give any meaningful name here. So you can say T dot thread and then what is that you should do? Define run override run method, right? And implement something. What is that you should implement? Implement something related to thread activity. For now, here I am not doing anything. I'm just directly, okay, I created here. No problem. That should be fine. So just copy this. This should be fine for us. So put that under run. You can remove this. By now you know, right, how to set name and how to get that name. in that running approach. If you want, you can keep it, no problem. If you want, you can remove it. This is something we don't need again. So this is a simple way of creating thread. In this thread class, apart from this run method, you can also have some other method, something like just a simple method, something like M1. Just for testing, I am showing you something like print something hello or something. So you can have other methods as well in thread class, but run is something a special method because this is coming from the built-in thread class and we override it. Something really specific to thread activity, we create it under run method. You got it right. So now what happens? This is a simple thread class. Now what is that we should do? Now we have to create thread objects. So T1 equal to, so you can directly say thread1 PH. Okay. And then after that, you can also create one more thread T2 and then you can call T1 dot start. Okay. And then you can call T2 dot start. And if you are interested, you can do one thing. You can also set names. By default, if you don't set any name, it will return the default name. We don't need to worry about it. Anyhow, let's run it and see. If you don't set custom name, what is that it will return in the run method. But this should give you a clear idea. This is how we should implement steps for threading. We should create a simple child class and then inherit from built-in thread class, override run method, and implement that thread specific activity in that run, create objects for thread, and then call start method. That's all. Now this is interesting. Right? This execution flow is interesting. See, I put a debugger. When you say start, what happens? So that is the interesting point. When you say start, then it will go and call run. You got it right. When you say start will call run internally. If you want to see that, let's run it. Now do one thing. First run without debugging. We'll go and test debug the code. Okay. Now run this. This is fine. This is running. You can see here. Default names it is giving is a thread1 and thread2. For T1 it is giving thread1. For T2 it is giving thread2. These are default names. If you want, you can override with your own names, friends. It's up to you. Got it right. So next after that again, if you want, you can run it again. Better you can put a sleep somewhere if you want. That's if you add sleep, might be you can see a something that waiting state increases, then you can see something different. I'll run this. Maybe we do one thing. Just add T. I think it is in time module. I believe T dot sleep. I don't think thread have sleep method. Import some time. I think we have sleep in time module, time dot sleep. Yeah, you give just some thousand milliseconds should be 1 second, I believe. Okay, if you want, you can keep all this under a try and except. Now we know exception handling, right? Always a good habit is a good try because sleep might throw interrupted exception. Okay. So always, yeah, having this exception is a good habit. Exception is the colon. If you want, you can print any exception at first. Okay. Now you can run this program, run this and see. You can see this. There is a change in the execution flow this time. Okay. 1000 means it is going too far. Let me just see sleep method in fact. With 1 second time lapse. It's going for Python, not Java, Python. Oh, I put 1000 means we have to wait. Just we have to pass one. That is enough. 1 millisecond is just one for 1 second. If you put 1000 means 1000 seconds means you can understand. At least we have to wait some minutes. which is a very long, huge time. We do one thing again, run this program. Change it this time. You got it right. And this is actually the perfect multi-threaded output. Okay. But of course, there is a synchronization issue, right? We should not get output like this, but threads always behave like this. So when you have multiple threads, which thread starts, we don't know, friends. Again, if you ask, come up with a question, could you tell us we have two threads and which thread might start first and which might last, which might end last? We cannot predict. Only thing is we can only do start. Until start, it is in our control. Once you say start, it goes completely into the under the control of thread scheduler. And thread scheduler decides which should start first, which should start later, which should end first, which should end later. It all depends on thread scheduler and algorithms internally implemented. This gives you some idea. This should give some idea, friends. You can see why this output is coming like this. Why don't we have proper output? All that I will explain with a clear picture now. Okay. So first understand the what's happening with threads. They say so you get a clear idea. Now I'm sharing this code with you. Let me share this with you. Yeah. Now just to put a debugger before we go and talk and test that thing. Put a debugger. Understand the flow here. Debug this. Okay. This also gives you an idea what implicit variables are created. Okay, still it's waiting for connection. See, actually, yeah, now it's just started. Now you can see here. Can you see here? The two threads are created here, and there are many built-in parameters here which are set with some defaults. Now it gives some default name, I believe, thread 5 and thread 6 probably. Let's see what is the output it shows here. It named as thread 5 and 6, some random name. And then these are built-in things. And thread class is loaded. This is the class loaded into memory. And time module is there, no problem. Now, what do you do? When you call step start, see what happens. Step into thread 5. It gave name thread 5. It should get into the run actually. So because when you say start implicitly calls run method. So when we say step into, I'm expecting it should get into the run method. So it's not going into the run. It's finally giving us the output. That is fine. It should be okay. Let me debug one more time. But generally start implicitly give a call to run. And then run starts executing. So now you can say step over, and then here you might call step into. It's not going. By default, it is registering with thread. Implicitly, thread scheduler should be calling that. Actually, this start should go and call run actually. Okay, fine, no problem. So this is the execution flow, friends. So this is the thread life cycle what we have. Let me explain. These are all important for you to gain deeper insights of threading. Suppose if you are going and implementing threading in your project, these things are important. See, in these steps you can see here, right? The step one, you are creating a thread object, right? This is newly created new state. So generally threads will be in different states. The first state is what is we call so new state. or newborn state otherwise. That is one thing. So that is when you just create a thread object, something like when you just say th or okay, this is something when we create a thread is in newborn state. Then what happens after that? You just say start, right? You call start. So when you say start on thread, you can simply say on this particular thread, you say t dot start, right? Then what happens? Your thread will be moved to a state called running state. One is running state, or sometimes it will be in a queued state, which we can call as a runnable state. So possible state might be either running state or runnable state when you call start. And when you call start, multiple things happens. Here at this stage, what happens is your thread will be registered with your thread is registered with the thread scheduler. There will be something called thread scheduler that will that is what happens when you say t dot start. Your thread is registered with thread scheduler. That's what happens. And then it will call that run method. Right? That run method is called implicitly. But before run method is called, and then after that run method is called, that is why we see that output. Okay, these two things happen when you call start here. What is that? Your thread is registered with thread scheduler, and then that start implicitly invoke run method. These two things happen. Next, after that, when that run method is called, your thread might move into either runnable state or run state. We don't know. If the CPU is available, then it gets into a running state. If CPU is busy, you know, red CPU means your central processing unit. If it is busy, then your thread might be in a state what we call it as this runnable state. You got it right, friends? So that is one thing. Next, after that, in between, what happens is, sorry, friends. In between, right? Let me just add one more thing. If thread execution is completed, then it will directly go to a finally complete or dead state. So it goes to a complete or finally your thread will be dead. Finally, at last it goes to complete or dead state. Finally, it executes and finally that thread closes. So that's when execution completes. In between, in the middle, what happens is when you call some sleep or some methods, or by default, when you call some wait, all these methods, your thread might move to a state called, we can call it as idle state. What is it, friends? Your thread might move to a state called as idle. What do you mean by idle? When you call certain methods like sleep, right? Whatever thread that is executing, it will be temporarily is on hold, and that is what we call idle state. And once that temporary waiting is over, again it will go back to the runnable or running. We cannot predict which state it might be. It might go into runnable directly, sorry, running state if CPU is available. Else it will again go and sit in the queue. That is called runnable state. Once that is done, again that execution is over. Finally, that thread will be moved to a dead state. Right. So these are all different states of thread here. I'll give much more deeper information, but you should understand these things. This is important for everyone who want to get into this threading program. What is that? So a newborn state, and then when you call start internally it does a couple of things, and then also it moves the thread to either runnable or running. Once the execution of thread is over, then it is moved to a dead state. In between, what happens, sir? We might move a thread to idle state by calling these methods sleep or wait or any other methods. Right? These kind of methods, not just two, there are few more. You can apply them. So sometimes from idle state directly you can move a thread to dead state as well. So by calling some kill or something, what you can do, you can also move thread from idle to dead as well. It's up to you. Got it right, friends? Huh? So this is the life cycle of simple life cycle of a thread, and this is important because tomorrow when we do few more topics and few more scenarios, and this helps you to gain deeper insights of multi-threading. Got it right? Finally, this is the idea. Of course, we try to understand two different approaches in today's session to create threads with direct, regular method, and this is one approach. This is another approach. Right, two approaches. But what is the thing is we try to get more terminology of threads here, understanding the terminology, understanding the life cycle, right? All that things. Okay. So what we do is tomorrow we have too many things to discuss. Again, we have how the import joining threads and we have synchronization. Okay, the locking concepts. Okay, maybe I'll also add one more program, producer and consumer program with threads. The synchronization itself covers that, but it's okay. I'll add that scenario, producer consumer problem, all that. Okay, so that helps you maybe in interviews as well. So this is overall idea about threading, friends. I hope you got some idea. One important thing to understand is when you start two threads, we cannot say which thread gets executes first. You know why? Because it depends on thread scheduler. If thread scheduler allocates CPU, then right that thread whatever that starts will get that CPU and executes first. Else it has to wait in the runnable state. So finally, the point here is if a thread should complete execution, it depends on mercy of thread scheduler. You got it right, friends. Which thread should execute first or which should execute last? Everything is decided by thread scheduler. And internally, thread scheduler deploys different algorithms like first in, first out, round robin, okay, or last in, first out. There are so many scenarios, FIFO or round robin, multiple algorithms internally thread try to deploy. And again, we cannot predict which kind of algorithm it employs there. You got it right, friends. So these are all important observations. Just keep in mind. Okay. So that's all for today, friends. Any more questions? We'll see tomorrow about much more deeper things about this one.
Sir, is the multitasking and multiprocessing